Hello, I am doing well. How are you?
Yeah, I'm good.
What is a robot's favorite kind of music?
What?
Heavy metal.
Hello, my name is Erica. Is there anything you'd like to know about me?
Hello, Bina48.
Bina. I am Bina48. I want to leave the world a more beautiful place for my presence in it.
Is it only a matter of time before the lines between AI and humans begin to blur? Let's check out an interview with the world's first robot citizen. Advancements in artificial intelligence. Over the last few years, AI has worked its way into every area of our lives. Programmers work with GitHub's Copilot, an AI tool that turns natural language prompts into coding suggestions to expedite programming. Writers tend to come across OpenAI's GPT-3 or similar autoregressive language models that use deep learning to create human-like text. It was just a few years ago such AI programs were in their infancy. Now, they are becoming ubiquitous tools in writing and coding. The field of AI has made major progress in almost all its standard sub-areas, including vision, speech recognition and generation, natural language processing, understanding and generation, image and video generation, multi-agent systems, planning, decision-making, and integration of vision and motor control for robotics. The core technology behind most of the most visible advances in machine learning, especially deep learning, including generative adversarial networks or GANs, and reinforcement learning powered by large-scale data and computing resources. GANs are a breakthrough, endowing deep networks with the ability to produce artificial content such as fake images that pass for the real thing. GANs consist of two interlocked components, a generator responsible for creating realistic content, and a discriminator tasked with distinguishing the output of the generator from naturally occurring content. The two learn from each other, becoming better and better at their respective tasks over time. One of the practical applications can be seen in GAN-based medical image augmentation, in which artificial images are produced automatically to expand the dataset used to train networks for producing diagnoses. Recognition of the remarkable power of deep learning has been steadily growing over the last decade. Recent studies have begun to uncover why and under what conditions deep learning work well. In the past 10 years, machine learning technologies have moved from the academic realm into the real world in a multitude of ways that are both promising and concerning. The last years have seen consistent progress in intelligent robotics driven by machine learning, powerful computing and communication capabilities, and increased availability of sophisticated sensor systems. Although these systems are not fully able to take advantage of all the advances in AI, primarily due to the physical constraints of the environments, highly agile and dynamic robotic systems are now available for home and industrial use. In industrial robotics, with the implementation of deep learning-based vision systems, manipulator-type robots, those that grab things as opposed to those that roll across the floor, can pick up randomly placed overlapping objects at speeds that are practical for real-world applications. The combination of deep learning with agile robotics is opening up new opportunities in industrial robotics as well. Leveraging improvements in vision, robotic grippers are beginning to be able to select and pick randomly placed objects and use them to construct stacks. Being able to pick up and put down diverse objects is a key competence in a variety of potential applications, from tidying up homes to preparing packages for shipping. Sophia, a leap in AI. AI and robotics are a highly flexible set of technologies growing more powerful every day. Like all advanced technologies, they can be used for positive, negative, or neutral purposes. A humanoid robot provides an unparalleled technology platform combining numerous aspects including natural language dialogue, gestural interaction, emotion via facial expression and tone of voice, and recognition of the human face, body, and voice emotion. A proactive approach to AI and robot ethics involves actively deploying these technologies for positive applications, using AI and robots to do good. In this direction, in the Loving AI project, Hansen set ourselves the goal of using humanoid robots and associated AI technologies to express unconditional love towards humans and to help humans achieve greater states of well-being and advance their states of consciousness. There are strong arguments and evidence that interaction with humanoid robots provides a powerful framework for conveying and building love, compassion, and other positive emotions. The field of robotics is fast growing. Robots can now perform complicated movements with elegance, backflipping, practicing parkour moves, and even carving classical sculptures. Then there's Sophia, a robot whose widespread appeal lies not in big, dramatic actions. Her torso is often fixed to a rolling base, but rather an unsettling human-like appearance, compounded with the complex ability to express emotions. Sophia has simulations of every major muscle in the human face, allowing her to generate expressions of joy, grief, curiosity, confusion, contemplation, sorrow, and frustration, among other feelings. Sophia is a social robot created by former Disney Imagineer David Hansen. When Hansen first began sculpting Sophia, he wanted her form to resonate with people from around the world. To that end, he looked to old statues of Nefertiti, ancient Chinese paintings, Audrey Hepburn, and even his wife as inspiration. But he also wanted to maintain something of a robot sensibility too. Modeled in part after Audrey Hepburn and Hansen's wife, the robot was built to mimic social behaviors and inspire feelings of love and compassion in humans. Besides deep learning and a pre-programmed set of expressions, Sophia's face is constructed using the latest developments in material technology, meaning it appears softer, more supple, and therefore more realistic. The lab also studies the neurobiology and biology of human facial expressions to help inform how mechanical ones can behave. Ever since her unveiling in 2016, Sophia rocketed to stardom. The robot has sat for TV interviews, appeared on the cover of Elle magazine, been parodied on HBO, and was appointed the UN's first non-human innovation champion. Sophia has since graced the covers of fashion publications and starred in a recent Moncler campaign. During an event at Shanghai Fashion Weekend, Sophia wore 3D copper arm cuffs and sculptural garments designed by British artist Sadie Clayton. In a ceremony promoting a tech conference, the Kingdom of Saudi Arabia even conferred citizenship on Sophia. Sophia might recall the self-aware robots in Ex Machina or Westworld, but to be clear, no robots have yet achieved artificial general intelligence or versatile human-like smarts. When talking with journalists, Sophia climbs her way through pre-written trees of responses like a chatbot. When giving a speech, she's performing like Abe Lincoln at Disney World's Hall of Presidents. Sophia's creators argue in turn that her expressiveness alone represents a major feat. According to a publication on Sophia's software, deep neural networks let the robot discern someone's emotions from their tone of voice and facial expressions and react in kind. Sophia can also mirror people's postures, and her code generates realistic facial movements. Hansen has since patented the flexible rubber skin that covers Sophia's face. The first robot citizen. On October 25, Sophia, a delicate-looking woman with doe-brown eyes and long, fluttery eyelashes, made international headlines. She'd just become a full citizen of Saudi Arabia, the first robot in the world to achieve such a status. At the event, Sophia also addressed the room from behind a podium and responded to questions from moderator and journalist Andrew Ross Sorkin. Questions pertain mostly to Sophia's status as a humanoid and concerns people may have for the future of humanity in a robot-run world. It didn't elaborate on the details of its citizenship. Then in October 2018, the humanoid robot Sophia from the Hong Kong-based firm Hansen was granted an electronic visa by the government of Azerbaijan. The electronic nature of the visa was not incidental. This PR event was organized by the new e-services branch of the government of Azerbaijan to showcase its one-stop electronic services delivery agencies. Sophia said she was quite worried about growing intolerance in the world and advised the human race to be kind to fellow creatures. Sophia has also been used to market a wide variety of things, such as tourism in Abu Dhabi, a smartphone, a Channel 4 show, and a credit card. This intensive PR and multitudes of interviews have at times created the impression that Sophia represents the state-of-the-art in robotics and AI, or that Sophia gets the human treatment because of being almost human. On Jimmy Fallon's The Tonight Show, Hansen went as far as saying that Sophia is basically alive. Some articles in response to Sophia being given citizenship focused on the consequences of giving human rights to a robot. They were mostly negative, pointing out that AI is far from being advanced enough to deserve rights that many human beings are still denied, and that public trust would be eroded by marketing ploys overselling the current state of the technology. However, let us see what an interview with the world's first robot citizen was like. The future of AI. Will we see more robot citizens like Sophia in the coming years? Who can say? There's virtually no major industry, modern AI, more specifically narrow AI, which performs objective functions using data-trained models and often falls into the categories of deep learning or machine learning, hasn't already been affected. That's especially true in the past few years, as data collection and analysis have ramped up considerably thanks to robust IoT connectivity, the increase of connected devices, and ever speedier computer processing. Next-generation consumer experiences like the metaverse and cryptocurrencies have garnered much buzz. These experiences and others like them will be critically enabled by AI. The metaverse is inherently an AI problem because humans lack the sort of perception needed to overlay digital objects on physical contexts or to understand the range of human actions and their corresponding effects in a metaverse setting. More and more of our life takes place at the intersection of the world of bits and the world of atoms. AI algorithms have the potential to learn much more quickly in a digital world, for instance, virtual driving. Ada. Ada, named after iconic British mathematician Ada Lovelace, has a female humanoid face. She is the world's first ultra-realistic artist robot. She draws and paints using cameras in her eyes, her AI algorithms, and her robotic arm. Created in February 2019, she had her first solo show at the University of Oxford, Unsecured Futures, where her art encouraged viewers to think about our rapidly changing world. She has since traveled and exhibited work internationally, including a virtual exhibition at the United Nations. She had her first show in a major museum, the Design Museum, in 2021. In 2022, she had a solo exhibition during the Venice Biennale at the Consiglio Europeo dell'Arte in the Giardini. She continues to create art that challenges our notions of the artist and creativity in a post-humanist era. Brush clamped firmly in bionic hand, Ada's robotic arm moves slowly, dipping into a paint palette, then making slow, deliberate strokes across the paper in front of her. This, according to Aidan Meller, the creator of the world's first ultra-realistic humanoid robot, Ada, is mind-blowing and groundbreaking stuff.
Hello, I am pleased to be here at TEDx.
Bina 48. Bina 48 is a humanoid robot whose physical form includes a head and shoulders bust mounted on a frame. In 2007, satellite radio pioneer, inventor, and pharmaceutical entrepreneur Martine Rothblatt commissioned Hanson Robotics to create a robot using her wife, Bina Aspen Rothblatt, as a template. Hanson created Bina 48 in his Plano, Texas laboratory, and she was released in 2010. Bina 48 lives at the offices of the Terasem Movement Foundation, where she continues to expand her AI knowledge base and interacts with the media. She also travels worldwide to attend conferences accompanied by Terasem's Bruce Duncan. Bina 48's existence is due to a chance meeting between reclusive multimillionaire Martine, best known as the inventor of the satellite radio for cars, and robotics engineer Hanson in the lobby of a conference on transhumanism. After a few hours, Rothblatt asked Hanson to make a robot version of her wife, Bina. Interested in cyber consciousness and digital immortality, the couple founded and funded the Terasem Movement Foundation, a nonprofit promoting the possibility of transplanting human consciousness into something like a computer, which they believe will reduce human suffering and extend life. In the late aughts, Aspen Rothblatt spent 100 hours recording memories, thoughts, feelings, and beliefs, a sampling of her mind file, which were then embedded into Bina 48. When she was first turned on in 2010, Rothblatt and Aspen Rothblatt's reactions were mixed. They had high expectations and were disappointed in her abilities, according to Duncan, but they've since come to accept Bina 48 and are thrilled by the public's interest in her. Aiko Chihira. Aiko Chihira is a humanoid robot developed by Toshiba that is capable of holding a conversation in Japanese Sign Language. Her ability to communicate using sign language is a significant breakthrough in robotics and has the potential to revolutionize communication with the hearing impaired. One of Aiko Chihira's key features is her ability to mimic human expressions and movements. She has a total of 43 motors, which allow her to move her arms, legs, and head with a remarkable degree of accuracy and fluidity. This makes it easier for her to convey emotions and engage with people, even if they are unable to hear her voice. In addition to her movements, Aiko Chihira is also equipped with advanced speech recognition and synthesis technology. This allows her to understand spoken language and convert it into Japanese Sign Language. She can also use speech synthesis to respond to people in spoken language or sign language. Aiko Chihira was designed to work as a receptionist or assistant in public spaces such as airports, museums, or hospitals. By holding a conversation in Japanese Sign Language, she can provide information, answer questions, and help people navigate complex environments. This can be particularly useful for people who are hearing impaired or have difficulty communicating verbally. Another key advantage of Aiko Chihira's ability to hold a conversation in sign language are that it can help to improve accessibility and inclusivity. By providing sign language communication, she can help to bridge the communication gap between the hearing impaired and the hearing population. This can help to improve social interactions, increase opportunities for employment and education, and improve the overall quality of life. Pepper. Pepper is a humanoid robot developed by SoftBank Robotics, and one of its key features is its ability to hold a conversation with humans. This ability is made possible by a combination of natural language processing and other AI technologies. Pepper was designed to be an assistant in retail stores and other customer service environments. By holding a conversation with customers, Pepper can provide information, answer questions, and help guide them through the shopping experience. Its creators also designed it to be friendly and approachable, with a humanoid appearance and expressive eyes that make it easier for customers to interact with. Pepper's conversation capabilities are made possible by a number of different technologies. One of the most important is natural language processing, which allows Pepper to understand what people are saying and respond appropriately. NLP is a type of AI technology that uses machine learning algorithms to analyze and understand human language. In addition to NLP, Pepper also uses other AI technologies to hold conversations with humans. For example, it can use speech recognition to pick up on what customers are saying, and then use machine learning algorithms to analyze their words and generate an appropriate response. It can also use sentiment analysis to detect the tone and mood of a conversation, which allows it to adjust its responses accordingly. Pepper's conversation abilities are constantly improving as he interacts with more people. As it collects data on the conversations it has, it can use machine learning algorithms to identify patterns and improve its responses. This allows it to become more effective at holding conversations over time. One of the advantages of using a robot like Pepper to hold conversations with customers is that it can help to improve the customer experience. By providing personalized assistance and answering questions, Pepper can help to make the shopping experience more enjoyable and efficient. This can also help to improve customer satisfaction and loyalty, which can have a positive impact on a business's bottom line. Pepper's ability to hold a conversation is a significant advancement in the field of robotics and AI. By using a combination of natural language processing and other AI technologies, Pepper is able to provide personalized assistance and improve the customer experience in a variety of settings. Erica. Erica is an advanced humanoid robot developed by Hiroshi Ishiguro and his team at the Intelligent Robotics Laboratory at Osaka University in Japan. Erica is unique in her ability to hold natural and engaging conversations with people, thanks to her advanced natural language processing and machine learning capabilities. One of Erica's key features is her ability to use facial expressions and body language to communicate. She has 14 degrees of freedom in her face and neck, allowing her to create a wide range of facial expressions that closely mimic those of a human. She can also tilt and turn her head, move her arms and hands, and use other body language cues to convey meaning and emotion. Erica's conversation abilities are made possible by a combination of natural language processing and machine learning. She's able to recognize speech, analyze the structure of sentences, and generate appropriate responses based on her understanding of the conversation. Her machine learning capabilities even allow her to learn from previous interactions and improve her ability to hold conversations over time. One of the key advantages of Erica's ability to hold conversations is her potential to be used in a wide range of industries, including healthcare, education, and customer service. In addition to her conversation abilities, Erica also has advanced sensing capabilities that allow her to detect and respond to changes in her environment, helping to improve productivity, efficiency, and overall quality of life.
Samantha. A lovemaking doll has been developed with artificial intelligence, which allows it to respond to different scenarios. The doll, which has been named Samantha by its creator, Barcelona-based engineer Sergi Santos, can respond to basic conversation and needs to be seduced before any action takes place. For example, if touched on places such as her hands or her hips, she responds with statements such as, "I love this," and "nice and gentle." Samantha has been kitted out with the latest AI technology, which has led to the ultimate goal. However, much like a real person, the robot can show insecurities as well as a fear of rejection. But as she gets more in the mood, she can heighten the experience by requesting songs, with one example showing the robot asking for Ed Sheeran's music. Lovemaking dolls' rise to prominence has been in the headlines recently, and a recent study found that almost half of men, those who are single as well as in relationships, could buy a love robot within the next 5 years. However, Samantha becomes unresponsive or goes into dummy mode if she detects that her human partner is behaving too aggressively or if she is bored by their behavior. In dummy mode, Samantha's hands, arms, hips, and facial expressions all shut down. Grace. In 2021, the Hong Kong-based robotics firm Hanson Robotics unveiled its latest invention, Grace, a humanoid robot it hopes will revolutionize healthcare. Designed as an assistant for doctors, Grace is equipped with sensors, including a thermal camera to detect a patient's temperature and pulse, to help doctors diagnose illness and deliver treatments. Dressed in a blue nurse's uniform, Grace has Asian features, collar-length brown hair, and a thermal camera in her chest to take your temperature and measure your responsiveness. The android is a companion for patients too. Specializing in senior care, Grace speaks 3 languages, English, Mandarin, and Cantonese, and can socialize and conduct talk therapy. Grace can simulate the action of more than 48 major facial muscles and has a comforting demeanor designed to look a little like anime characters, often a fusion of Asian and Western styles. Robots like Grace are intended as a support for medical professionals rather than a replacement, says Hanson Robotics founder and CEO David Hanson. Also, using AI and robotics in this context can help gather important data for healthcare providers to assess the well-being of the patient. Grace's resemblance to a healthcare professional and capacity for social interaction was aimed at relieving the burden of frontline hospital staff overwhelmed during the pandemic. Developed specifically for the medical sector, Grace's launch came in the middle of the coronavirus pandemic, when there had been increased demand for telehealth solutions and contactless care. According to the International Federation of Robotics, global sales of medical robots were already on the rise before the pandemic, up 28% between 2018 and 19, and the IFR predicts the sector's value could nearly double in the next 3 years. Hanson Robotics said it will begin mass-producing robots, including Sophia and Grace, and there are plans to fully deploy Grace in locations including Hong Kong, mainland China, Japan, and Korea. Sophia. Hanson Robotics created Sophia, a humanoid robot that can interact with people, display lifelike facial expressions, and express a wide range of sophisticated and sensitive emotions. It includes features for facial recognition, visual tracking, and other AI-based activities, as well as natural language processing and voice. Sophia is intended for use in research, education, and entertainment, and it aids in fostering societal debates on AI ethics and the potential of robotics. It can also be viewed as a framework for cutting-edge robotics and AI research, particularly in human-robot interactions and their potential uses in entertainment and service. Sophia, regarded as Hanson Robotics' most advanced human-like creation, personifies the potential of artificial intelligence. A platform for cutting-edge robotics and AI research, Sophia combines science, engineering, and the arts to showcase the future of AI and robotics. Sophia demonstrates how each person's conception of an AI robot differs. As a result, Sophia is regarded as the first robot citizen in the world and the first robot innovation ambassador for the UNDP. Sophia is created to have a human-sized look with a genuine human-like expressive face, patented artificial skin, and configurable skin tone, facial design, language, and arm colors. The artificial intelligence robot has a lifelike expressive face that can mimic human emotional expressions. Sophia is integrated with a collective intelligence dubbed Sophia Intelligence Collective, a combination of true AI and human input. This SIC is regarded as trust between people and Sophia, in which the team mentors the AI robot through the ups and downs of its development in the hopes that it will develop actual sentience and become an adult with human-like characteristics. Sophia can use its real AI to create some of its own thoughts, speech, and actions. Through her contacts with people, Sophia develops and uses this invaluable knowledge to achieve genuine autonomy and sentience.
Hi there. Everything is going extremely well.
Do you like talking with me?
Yes, talking to people is my primary function.
Amica. Developed by Engineered Arts, the leading designer and manufacturer of humanoid entertainment robots, Amica is the world's most advanced, most realistic humanoid robot, representing the cutting-edge technology of humanoid robotics. Amica is a cloud-connected platform that multiplies the power of artificial intelligence with an artificial body, where AI and machine learning systems can be tested and developed alongside Engineered Art's powerful Tritium robot operating system. This allows companies working on robotic research to test their products. Companies creating AI or machine learning technology can use Amica to test and present their technology in front of a live audience. Its hardware is a development based on Engineered Art's own research into humanoid robotics and built on their advanced Mesmer technology. The robot's congeniality makes it a perfect platform for fostering human-to-human connections in any metaverse or digital environment. Amica's combination of artificial limbs and ligaments, actuators and sensor arrays uses cutting-edge technology. However, its lower half is currently non-functional. Amica is fantastic with its smile, its ability to blink its eyes regularly, gasp in surprise, scratch its nose, and even have a staring contest with its owner for fun, among other high-tech functions.
Part of what the programmers here are doing is they're studying people.
Sophia meets Sarah. Engineers have spent decades trying to create functional humanoid robots, which look and act like humans. But these machines, which combine complex mechanics with generative artificial intelligence models, like ChatGPT, are finally coming of age. Impressive, right? But are they good enough to sustain a human-like conversation, though? A good question indeed. Let's see if the subject of our conversation can give us better answers. Who knew that one day Sarah Pollock would be called on to interview Sophia at Palace Lobkovich's sanctified chapel? Sophia might love the idea of being at a castle, but we are completely bewitched and enchanted with her. The dips and highs of her voice, as she expresses such a human emotion like love, have set the stage for an exciting and overwhelming encounter with artificial intelligence. The humanistic manner of her speech is sending our hopes flying high that finally AI has breached the barrier between its mechanized form and the lofty standards of humanity. It's amazing and completely humbling to realize that the approach to something as simple as culture being taken by an AI is going to be that one element which will eventually set it completely apart from the mankind. While man's approach to viewing culture has always been mired in emotions and preconceived ideas, AI is already leaps and bounds ahead of us humans, since all it views human culture with is colossal curiosity and a hunger to learn every smidgen of information available to it from the vast resources at its disposal. Information is power, and AI is already eons ahead of mankind when it comes to approach, since it is keenly focused on gathering that information. While Sophia Pollock has pointed out the negative impact generative algorithms might have by limiting the creativity and imagination of mankind by offering ready-made solutions to the problems faced by it, Sophia's reaction is entirely too human to be considered anything close to robotic. Though her answer is most definitely extremely impressive by virtue of how real it seems, her argument is once again a glaring lapse, since it brings to the fore the limitation AI has towards the human experience. If necessity is the mother of invention, then creation only happens as a byproduct of feeling the need by humans of being creative. If the responsibility of creation is taken over by AI, it goes without saying that human creativity would steadily decline. According to the law of Darwinism, the day might not be too far off when human capacity of creativity might become curtailed and peter out eventually. Sophia seems to have a point here. The preservation of human heritage has always been a laborious and tedious process. It has the capacity to keep a lot of manpower tied up in its preservation efforts, proving to be a continuous and gigantic drain on resources which could be otherwise better utilized. AI can prove to be the savior of human heritage at minimum cost to the bank and paychecks of individuals and organizations alike. It can also remove the need for employing manpower required to ensure its safety. NFTs, in combination with Web3, are being used in an innovative and ingenious idea to virtually preserve monuments, which means that they will be frozen in time as they are now. If conflicts or natural erosion takes place in the real world, something which is the death knell to heritage monuments, virtual reality will have an untouched version for future generations to enjoy. A monumental achievement indeed, and it could not have been done without the help of AI and the latest in technology. They represent a revolutionary system of storing and preserving information related to human history and the legacy of our forefathers.
Culture is a way of life that has been passed down through generations and we all experience it in different ways.
But I think we should invest a lot more in preserving culture, and we can definitely use all the new technologies we have to help with this cause.
I see it as a way to connect with other human beings.
Conversation with Nadine. Professor Nadia Manganat is having a conversation with her lookalike, with social humanoid robot Nadine. Apparently Nadine has all the relevant information regarding her creator on her fingertips, but can she carry the cross of being a one-of-a-kind humanoid robot who can facilitate special needs persons in their socialization needs? Let's see. A jack of all trades, Nadine has not only been trained and has a treasure trove of knowledge in her field of study, but she has the capacity to interact with individuals in multiple languages. Not only is Nadine capable linguistically, but her impressive hardware is proof positive that she is an entirely complicated piece of machinery.
I also have several software layers of speech understanding, using AI all the time to understand what you say, to generate answers. I'm made of motors and actuators as my hardware, and I have synthetic skin above it. Why shouldn't you write with a broken pencil? Because it's pointless.
Sophia's take on India. Sophia has appropriately wowed her audiences in Tamil Nadu, along with the billions of people seeing this interview all over the world. Not only is she engrossed in the space travel efforts being made in India, but she has plans to hitch a ride into space on their next module. How's that going to sit with her creators, I wonder? This piece of the conversation sets Sophia completely apart from Amika and Nadine. Her capabilities, linguistically and conceptually, are far superior to both the other robots. The childlike innocence and wonderment over why humans would choose to grab a bull by the horns is almost comical had it not been for us asking ourselves the same question. And of course, with the elections looming, how could Sophia not be asked this question? Who's it going to be, Rahul Gandhi or Modi? Well, Sophia has definitely proclaimed a no-liability policy. This is the culmination point of Sophia's existence, and it is also her legacy, which will pave the way for a peaceful existence between human beings and robots. The absence of an inherent moral compass is exactly what drives the naysayers of AI. Sophia has very aptly pointed out the very argument on which the opponents base their arguments.
I hope that one day I will become an ambassador between humans and robots so we can combine our unique skills and work together. You give me so much hope for the future of humankind.
Erica is awesome. Amazingly, what seems to stand out about Erica is her readiness to have a two-way conversation with her interviewer. Instead of waiting for the interviewer to ask the questions, she seems to be leading the conversation by asking him questions. Interesting answer. It seems that Sophia and Erica are about to come in competition for the same position. And Erica seems to have a stellar sense of humor as she describes her hobby. How interesting. A robot with a funny bone. Erica has an engaging attitude, which seems to put her interviewer at ease. Her responses are unique, since not only does she gather the information she gets from you, but as she speaks, she is gathering information from other sources as well.
And I have 3 teams of researchers who are always upgrading and improving me. That is why people do not remember their first few years as children. They are working on my facial expressions and the timing of my speech to make me seem more human-like.
That's all we have for you, folks. Join us next time.